Hypervisors. Minus type 1. Minus type 2. Think of a hypervisor, or a virtual machine monitor, as the grand architect of a virtualized environment. Its sole purpose is to act as a middleman between the physical hardware of a computer and the multiple guest operating systems that want to use that hardware. In a traditional, non-virtualized setup, an operating system like Ubuntu owns the entire computer. It has direct, exclusive control over the CPU, the RAM, and the hard drive. A hypervisor changes this dynamic. It abstracts or hides the physical hardware, creating a layer of software that allows you to slice one powerful physical machine into dozens of smaller, independent virtual ones. As you move toward your career in cybersecurity, the hypervisor is the most important piece of infrastructure you will manage. It is the foundation of the cloud and the tool that allows you to build complex, isolated labs. For the A+ exam, you must distinguish between the two primary ways this software can be installed: Type 1 and Type 2. Part 1. Type 1 Hypervisors, the bare metal. A Type 1 hypervisor is often called a bare metal hypervisor because of where it sits. It is installed directly onto the hard drive of the physical server, exactly like an operating system would be. There is no Windows, Mac OS, or Linux underneath it. The hypervisor is the foundation. When you hit the power button on a server running a Type 1 hypervisor, the very first thing that loads after the BIOS is the hypervisor itself. Common examples include VMware ESXi, Microsoft Hyper-V Server, and the open-source Proxmox. The architecture of efficiency. Because there is no middleman operating system, a Type 1 hypervisor is incredibly fast and efficient. It has direct access to the physical hardware. When a virtual machine needs to perform a calculation, the Type 1 hypervisor passes that request directly to the Intel or AMD processor with almost zero delay. The cybersecurity advantage. From a security perspective, Type 1 is the gold standard. Because the hypervisor is a very small, specialized piece of software, it has a tiny attack surface. There are no web browsers, media players, or extra background services for a hacker to exploit. This makes it much harder for an attacker to perform a VM escape, where they break out of a virtual machine to take over the physical host. Use cases. You will find Type 1 hypervisors in data centers, government agencies, and enterprise server rooms. If you are building a system that needs to stay online 24 hours a day and manage hundreds of users, Type 1 is the mandatory choice. Part 2. Type 2 hypervisors, the hosted model. A Type 2 hypervisor is known as a hosted hypervisor. Unlike its bare metal sibling, it does not sit directly on the hardware. Instead, it runs as an application inside a regular operating system. Imagine you are running Ubuntu as your main system. You open your applications folder and launch Oracle VirtualBox or VMware Workstation. In this scenario, Ubuntu is the host, and the hypervisor is just another program running on top of it. The architecture of convenience. Type 2 hypervisors are much easier to set up. You don't need to wipe your hard drive or dedicate a whole server to them. You just install the software and start creating virtual machines. However, this convenience comes at a cost: performance. Every time a virtual machine wants to do something, the request has to travel through several layers. The guest OS, the virtual machine. The Type 2 hypervisor software. The host OS, Ubuntu. The physical hardware. This extra hop through the host operating system creates latency. While this is fine for a lab or testing a new script, it is not efficient enough for a high-traffic production server. The security trade-off. The biggest risk with a Type 2 hypervisor is the host dependency. If your main Ubuntu system gets infected with a virus, that virus can potentially see and interfere with every virtual machine running inside your hypervisor. Your security is only as strong as the host operating system it is sitting on. Use cases. Type 2 hypervisors are the primary tool for students, developers, and cybersecurity researchers. They allow you to turn your personal workstation into a multi-OS powerhouse where you can run Windows, Kali Linux, and specialized security tools all at the same time without needing extra hardware. Part 3. Resource allocation and VT technology. Regardless of which type of hypervisor you choose, the software cannot work its magic unless the physical CPU supports it. You must ensure that virtualization technology, known as Intel VTX or AMD, is enabled in the motherboard settings. CPU and RAM budgeting. A hypervisor is essentially a resource accountant. It has to decide how to divvy up the physical parts of your computer. vCPU, virtual CPU. The hypervisor allows you to assign specific cores to each virtual machine. You can even over-provision, telling 5 different virtual machines they each have 4 cores, even if you only have 8 physical cores. The hypervisor manages the time sharing to make sure everyone gets a turn. RAM. Unlike the CPU, RAM is a hard limit. If you have 32 gigabytes of RAM and you give a Windows VM 16 gigabytes, that memory is physically reserved. The hypervisor ensures that one VM cannot bleed into the memory space of another, which is a critical security feature. Part 4. The snapshot and live migration. 2 of the most powerful features managed by the hypervisor are snapshots and live migration. The snapshot is a save point for the entire computer. Before you run a dangerous security test or install an unverified update, the hypervisor can take a picture of the VM's entire state, including the memory and the hard drive. If the test fails or the update crashes the system, the hypervisor can revert the VM to that exact moment in time in a matter of seconds. Live migration, often called vMotion in the VMware world, is a feature exclusive to professional Type 1 environments. It allows the hypervisor to move a running virtual machine from one physical server to another over the network with zero downtime. The users logged into that VM won't even notice their computer, just jumped across the room to a different piece of hardware. Summary for the A+ exam. To lock this in for your exam, remember these 4 core distinctions. First, Type 1 is bare metal. It is faster, more secure, and is installed directly onto the physical hardware. It is the standard for servers and data centers. Second, Type 2 is hosted. It runs as an application inside an existing operating system like Ubuntu or Windows. It is best for labs, testing, and personal use. Third, the hypervisor is the referee. It manages the guest operating systems and ensures they share the physical CPU, RAM, and storage safely and efficiently. Finally, hardware support is mandatory. You must enable virtualization support in the BIOS or UEFI for any hypervisor to function at full speed.